Hey there, I'm TJ Van Tol, and I'm a principal developer advocate at Blues. Today, I want to introduce you to a new product of ours, and that's Notecard for Skylo. Notecard for Skylo is a first for us at Blues as it offers connectivity over 3 different radio access technologies: Wi-Fi, narrowband cellular, and satellite using Skylo's satellite network. Like all Notecards though, we designed Notecard for Skylo to make connectivity really simple for developers. There are no SIM cards for you to manage and no monthly minimum usage. The module ships with 10 years of cellular service and 500 megabytes of cellular data, as well as 10 kilobytes of satellite data. Now, there's a lot more to talk about with this product, and I think the easiest way to do that is by showing it off in action. So that's what we're going to do. In this video, you'll learn everything you need to know about Notecard for Skylo, including how to set up your hardware, how to manage multiple different radio access technologies, and then you're gonna head outside with me, and we're gonna use this thing to send some data to space. It's gonna be fun. Let's get started. All right, I wanna start by just showing off the hardware. Notecard for Skylo is 30 by 42 millimeters, which is the same size as a Notecard Cell Plus Wi-Fi if you used one of those before. Notecard for Skylo ships with 2 flexible antennas. One bigger antenna that covers a pretty wide frequency range and is used for both satellite and cellular communications, and one smaller antenna that's tuned specifically for GPS reception. Notecard for Skylo has the same M.2 edge connector that all other Notecards use, which means that it's compatible with all Blues Note carriers. And you will need a Note carrier to try out Notecard for Skylo, as you'll need a way to power the device and to configure it, which we're going to do in a minute. First though, I'm going to put mine in a Note Carrier X magically here real quick, and I'm going to use this Note Carrier for my demo, but again, any Note Carrier you want to use will work. And while we're still looking at hardware, I want to quickly compare Notecard for Skylo to the other Skylo product we offer at Blues, StarNote for Skylo. The one thing that both products share is the ability to perform NTN or non-terrestrial network communication on Skylo's satellite network. Beyond that though, the products are totally different. StarNote for Skylo is a Notecard accessory and only functions when paired with a Notecard using a Note Carrier XS. Notecard for Skylo is a fully fledged Notecard and can communicate over cellular and satellite completely on its own. Notecard for Skylo uses the same modem to communicate over cellular and satellite, which is powerful, but it does mean that when Notecard for Skylo communicates over cellular, it can only do so using narrowband technologies, specifically LTE Cat-M and NB-IoT. If narrowband cellular is sufficient for your needs, then Notecard for Skylo is likely the better fit for your project. But if it's not, you'll need to use a midband or wideband Notecard and pair it with a StarNote for Skylo. Okay, with that comparison out of the way, let's get to the demo portion of this video and get our Notecard for Skylo configured. All right, what you're seeing here is my desktop open to the new quick start we have available for Notecard for Skylo. And there's a link to this tutorial in this video's description if you want to follow along. And what we're gonna do is go through most of this guide together. You'll see that the quick start opens up with instructions on how to hook up your hardware, so how to connect your Notecard to a Note carrier, and then how to hook up antennas. And then the next step is it's going to ask us to connect a USB cable from our Note carrier to our computer, which you'll see for me, I've got this Note Carrier X I showed a minute ago, hooked up and ready to go. And then it'll tell us to connect to the in-browser terminal, which is in this pane over here on the right. And what this does is it forms a serial connection with our Notecard, and it allows us to send requests. Skipping down a bit, the first request we're going to send to our Notecard is this card.transport request. Card.transport controls how Notecard picks what radio access technology it should use for connectivity. The default card.transport on Notecard for Skylo, if I run this real quick, is Wi-Fi-cell, which tells Notecard to communicate over Wi-Fi by default and to fall back to cellular if Wi-Fi connectivity is not available. This makes some intuitive sense because generally speaking in connected products, you want to communicate over the cheapest and fastest protocols first if they're available, and fall back to slower and more expensive protocols as necessary. Notice though that we don't fall back to satellite by default, and we made that the default on purpose. Because satellite data is so much more expensive, we wanted to make sure that satellite, or NTN for non-terrestrial networks, was opt-in. And therefore, we require you to change your card.transport method explicitly in order to use it. There are a handful of other card.transport options available, like cell-NTN or Wi-Fi-cell-NTN, or you can just use NTN directly. But as the tutorial says here in bold, we don't want to do that quite yet, as there are two prerequisites that we have to take care of first. The first, just scrolling down a bit, is to create and sync any compact templates you want to use. This is a requirement we have at Blues for all of the low bandwidth protocols that we support. Compact templates tell Notecard and NoteHub about the structure of your data, and basically they just help us send your data more efficiently to minimize bandwidth use. And I'm not going to read through what every field does here. You can read through this later if you're curious of all the details. We definitely recommend this as you're going through this tutorial on your own. But just skipping down to the steps, the next step the tutorial is going to have us do is take this note.template request and run it on our Notecard, which sets up this sat.q, sets up a template for this sat.qo note file that contains temp and humidity fields. Next, the tutorial has us set our Notecard to minimum mode, which tells Notecard to only connect to NoteHub during explicit hub.sync requests. This isn't a mode we normally recommend for cellular Notecards, but it's another way to help us minimize data usage when doing satellite-based communications. And then next, our next step is to again use this hub.set request, this time to set the product UID of the NoteHub project that we want to use. And I've got an empty one ready over here that I will copy and paste in there to set that up. And then with that done, we can then do a sync to associate this Notecard with our NoteHub project and to sync that template that we just set up. Because I haven't configured a Wi-Fi network on this Notecard, it's going to go straight to cellular and send that template we just configured to NoteHub using a cellular connection. But remember, this is a narrowband Notecard, so know that it may take a minute or two to connect, especially the first time, and it will be a little bit slower, especially if you are used to using midband or wideband cellular Notecards before. And I did edit this video a bit, but it took about a minute or two to connect from my desk here. And once it's connected, I can go back to my NoteHub project and see that this device is here and that it connected over a cellular connection. And I know this is a video about satellite, but I do still think it's worth taking a second to point out how cool it is that cellular on Notecard just works out of the box that easily. And switching back to our tutorial, the last thing this is going to have us do is add a note to that note file that we just created. So I'll go ahead and do that. And we'll do one more hub.sync again to take that note and synchronize it up to NoteHub. And we'll give that a second to run. And it looks like it just finished. So what I can do is I can go back to my NoteHub project and go over to the event screen. And you'll see that our humidity and our temperature made it through. And if I hover over this icon over here, you can see this data was sent over a cellular connection. And now that we have that data sent and we know our note file is in place, we can send data. That brings us down, scrolling down a bit, to our second prerequisite, and that is providing a location. Notecard requires a location before communicating with Skylo's satellite network. And at a high level, there are two different ways that you can provide it. The first is you can enable Notecard's GPS module with the card.location.mode request. This is the configuration we recommend using for production scenarios, as it tells Notecard to dynamically retrieve its location using its onboard GPS module. And Notecard with this request is also smart enough to only get a new location if the device moves, so that your device doesn't waste power unnecessarily when it really doesn't need to get a new location. The second option, scrolling down a bit, is to provide a fixed location, which is what we recommend for initial testing, just because it's faster. And when you're testing new hardware, especially hardware that you have to take outdoors, you typically want to see things working as soon as possible, and hard coding in your location is the easiest way to do that. What I typically do is grab my coordinates from an online tool. I just grabbed them from this site I found from a quick Google search, and then I'll paste them in and use them for the card.location.mode request. I will run this, and then I'll go ahead and also run this ntn.gps request, which tells Notecard to use that fixed location for NTN purposes. And with that done, we're ready to use NTN mode for real. To do so, we'll scroll down to this last section and go to our last set of steps. And we're going to start by turning on trace mode on our Notecard, which basically just tells Notecard to do some more verbose debug logging as it attempts to make a connection, and you'll see what that looks like in a minute. Next, we'll change our card.transport again. This time we will actually set this to NTN so that it actually uses a non-terrestrial network connection. Generally speaking, we don't recommend using NTN mode directly in a production scenario, and to instead use NTN only as a fallback from Wi-Fi and/or cellular. But for testing like we're doing here, it's definitely the fastest way to communicate over satellite. So I'll go ahead and run that. Next, I'll queue up one more note on our Notecard. This is essentially the same thing that we did earlier when we were sending data over cellular, except this time we're going to attempt to send this note over an NTN connection. Then our last step to scroll down here is to perform a sync. Remember that we set this Notecard to minimum mode, so this hub.sync is required in order to send this data. And because this data is going to be sent over satellite, we do have one final thing to do. As you can see, this bold text over here tells us we have to test this in a location that has a clear view of the sky. So to do that, let's head outside. All right, welcome to my deck, which is my satellite testing location of choice. And I like this spot because I have a reasonably clear view of the southern sky, which is in this direction for me. Now, Skylo's network uses geostationary satellites that orbit the equator. So having a reasonably clear view of the equator is pretty important when you're testing out your hardware. Now, I'm in the northern hemisphere, so for me, that means a clear view south. And for those of you in the southern hemisphere, that's going to mean a clear view of the northern sky. Now, I've got my hardware hooked up to my laptop down over here over USB-C. So I'm going to go ahead and run that hub.sync request now that I'm outdoors. And I'll capture my screen for a few minutes, but through the magic of video editing, we're going to go inside to see what happened. All right, so I'm back inside and playing through my screen recording. And while that runs, I just wanted to give you a few last tips. The first is that you may wish to connect a LiPo battery to your note carrier before you take your device outside. Having a battery attached will mean that your Notecard will stay powered as you disconnect and reconnect it while testing. And then second, if you do disconnect your Notecard, you may need to re-enable your trace log, which you might have seen at the start of this recording that I needed to do. And having that trace log enabled so that you can see debugging messages can really be a valuable reassurance as you are waiting for your device to connect. And all of this is kind of wild, honestly, because Skylo's satellites orbit 22,000 miles above the equator, which breaks my brain just a little bit. And it does mean it's pretty awesome when you get to see all of this working. And to see that, I'll go ahead and fast forward to the end here. And you'll know things work when you see this ntn.uplink message, which means that Notecard was able to connect to the NTN network and transmit data. When you get to that point, and I'll just go ahead and switch over to my live screen, you can go back to your NoteHub project, and this time we'll go to our events screen, and you'll see there is our second sat.qo note with this updated humidity and temperature. And if I hover over the transport, you can see that it was sent over Skylo's satellite network. In this video, we took a thorough look at how to use Notecard for Skylo, our new all-in-one solution for connectivity over cellular, Wi-Fi, and satellite. If you'd like to try Notecard for Skylo, it's available in our shop for $89, and there's a link to it in this video's description. Remember that you'll also need a Blues note carrier as well if you don't already have one. If you have any other questions about how Notecard for Skylo works, or if there are some things I didn't cover in the video today, the best place to reach out with those is in our community forum at discuss.blues.com.